Hello everybody. Once again I am here with you for the another session of the modulation and demodulation. Today we will see the frequency spectrum of AM waves, that is amplitude modulation waves. Actually amplitude modulation is there, but the frequency spectrum what is gives, that we will see in this amplitude modulation. Actually we have seen what is the expression for the amplitude modulation waves. Related with the same point, that we have seen the expression for the modulated wave, and that is given with E is equal to EC into 1 plus MA cos of omega mt cos of omega ct is there. So if we multiply this EC and cos of omega ct, then we will have the relation EC cos of omega ct plus here एकला जर मल्टिप्लाय केलं EC आणि cos of omega ct नी, तर मला मिळते EC cos of omega ct प्लस आता EC नी जे आहे त्या MA cos of omega mt ला जर मल्टिप्लाय केलं तर MA EC cos of omega ct आणि cos of omega mt likewise हे multiplication मिळते. So if we reshuffle this and rearranging this, we will have 2 नी मल्टिप्लाय केला आणि 2 नी जर डिवाइड केलं तर काहीच फरक पडत नाही, पण इक्वेशन मध्ये कसा फरक पडतो बघा. सो वी हॅव EC cos of omega ct as it is plus MA EC by 2 into 2 into cos of omega ct cos of omega mt. And another important trigonometric relationship, if we know at the 12th standard 12वीला आपण जे काही ट्रिग्नोमेट्रिक रिलेशनशिप्स बघितले त्याच्यामध्ये 2 cos A आणि cos B याला आपण जनरली लिहू शकतो cos A plus B plus cos A minus B. So we have the relation that is here EC cos of omega ct as it is, MA EC by 2 as it is. Here 2 cos A cos B म्हणजेच 2 cos omega ct cos omega mt ला आपण लिहू शकतो MA EC by 2 cos of omega C plus omega m into t plus cos of omega C minus omega m into t. So reshuffling and rearranging again, this is what the trigonometric relationship EC cos of omega ct plus MA EC by 2 into cos of omega C plus omega m into t plus separately त्याला multiply केलं तर MA plus MA EC by 2 cos of omega C minus omega m into t. This will be the final relation for the amplitude modulation waves. But what it exactly contains, that is quite interesting. And if you see this equation carefully, this is somehow EC cos of omega ct. It is generally a carrier wave relation. जनरली कॅरियर व्होल्टेजचं एक्सप्रेशन रिप्रेझेंट करते. आणि दुसरं जे एक्सप्रेशन आहे MA EC by 2 cos of omega C plus omega m into t, हे सम ऑफ दी कॅरियर आणि मॉड्युलेटेड फ्रिक्वेन्सी सम इंडिकेट करणारा एक्सप्रेशन आहे. आणि MA EC by 2 cos of omega C minus omega m हे डिफरन्स ऑफ द कॅरियर फ्रिक्वेन्सी अँड मॉड्युलेटेड फ्रिक्वेन्सी याचं रिलेशन असणारं एक्सप्रेशन. So these are the three parameters or the three expressions we have in this expression, that is amplitude modulation waves. Now these additions or differences, sum and the differences, somehow it is called as a upper side frequency and the lower side frequency. Addition is called as a sum is called as a upper side frequency, and the subtraction of the carrier frequency and the modulated frequency is called as a our lower side frequency. Also these side frequencies also a group in called as a sidebands, or the upper sideband and the lower sideband we can easily say. The sideband requires for the transmission of an amplitude modulated radio frequency signal is equal to twice the highest modulating frequency. म्हणजे ह्याला जे काय मल्टिप्लाइड आहे MA EC by 2, the twice the highest modulation in frequency in that case is ह्या एक्सप्रेशन मध्ये इक्वेशन 1 मध्ये जर बघताल तर बेसिकली वी हॅव this EC cos of omega ct, that is original carrier voltage, MA EC by 2 cos of omega C plus omega m upper sideband of angular frequency omega c plus omega m, ma is c by 2 cos of omega c minus omega m, that is lower sideband of angular frequency omega c minus omega m. So this is what the another one expression, or the completely modulation amplitude modulation frequency contains three: original carrier, upper sideband, and the lower sideband. Now lower sideband and the upper sideband term are located in frequency spectrum of either side of the carrier at the frequency intervals of omega m, and the magnitude of both the sideband is ma by 2 times the carrier amplitude ec, and if ma is equal to 1, then the sidebands is half the carrier voltage in the amplitude. म्हणजे जर ह्या दोन्ही एक्सप्रेशन मध्ये जर बघताल तर अप्पर साइड बँड अँड लोअर साइड बँड हा मल्टिप्लाइड विथ एम ए ई सी बाय 2 आहे, आणि ई सी कोण आहे ॲम्प्लिट्यूड ऑफ द कॅरियर व्होल्टेज किंवा कॅरियर वेव्ह आहे, आणि एम ए जर समजा मॉड्युलेशन इंडेक्स 100% असेल तर इट इज हाफ ऑफ द कॅरियर ॲम्प्लिट्यूडच्या पार्टमध्ये राहते. हाच त्याच्या मागचा उद्देश सांगण्याचा. साईड बँड्सच्या बाबतीमध्ये जेव्हा आपण बोलतो देन द हाफ ऑफ द कॅरियर व्होल्टेज इन द ॲम्प्लिट्यूड आपण फॉर्ममध्ये म्हणूयात. जर फ्रिक्वेन्सी स्पेक्ट्रम ऑफ ॲम्प्लिट्यूड मॉड्युलेशन वेव्हजच्या बाबतीमध्ये जर बघायचं राहिलं voltage, it is given in this fashion also, and if you look at this is what the relative amplitudes, omega c or the ec is the carrier voltage or the carrier frequency in that form. ec is nothing but to be the carrier amplitude part, आणि त्याची omega c that is carrier frequency part. Upper sideband is omega c plus omega m, that is called upper sideband. This is another side, lower sideband, omega c minus omega m, and this is omega m means amplitude modulation em, amplitude is to be there, and that is the frequency of the modulated wave and omega c is the frequency of the carrier wave. So this is what the relationships are there. And if we take one example of the frequencies, that is, if suppose omega c carrier frequency is 1000 kilohertz and the modulated frequency is 1 kilohertz, so in that case if I want to say the upper side band will be omega c plus omega m, means 1000 plus 1, that will be 1001 kilohertz, that will be upper side band, and the lower side band frequency is omega c minus omega m, that is 1000 minus 1, that is 999 kilohertz. So this is what the upper side band, lower side bands, and the carrier amplitude voltage in the modulated frequency spectrum. So this is what about the amplitude modulated voltage having the different frequencies, that is the carrier frequency and the lower and upper side bands are to be there. Thank you for joining this session. Be at home and be safe. Thank you.